Hello everyone. Let's understand the difference between printing inside a function and returning from a function. When you print a value inside the function, you cannot do anything with the printed value in the place where you are calling that function. That's because the printed values directly go to the display output screen. As opposed to that, if you were to return a value from a function, you'll be able to manipulate that value in the place where you're calling that function. The best thing for you to do with a function's return value would be to capture that into a variable. Once you have done that, you can use that variable for further computation or for calling the print function yourself. Let me give you an example. Let's say that I have a function which is printing 1324 to the screen. Instead, if I were to return these values, I'll be able to create a bar plot where the bars have a height of 1, 3, 2 and 4. I'll also be able to do other manipulations with this returned value. It is always recommended for you to give preference to returning instead of printing. That's because this provides flexibility to the people who are calling your function in terms of how to use the result from the function. We went through demo for dog module. Let's create a cat module. I'm going to switch to my Jupyter Notebook homepage, click on New and click on Text File. Let's rename untitled.txt to cat.py. This is how you can create a script file inside your Jupyter Notebook session. I'm going to rearrange the module windows in such a way that we are able to see both the modules and the main notebook file. Let me create a speak function inside cat module by typing in def space speak, open parenthesis, close parenthesis, and a colon. Within the speak function, I'm going to call the print function call to display meow. Let's save the cat.py file. Whenever you want to use custom modules, you need to make sure that the module files are in the same directory location as the place that you want to use those functions. I want to use the cat and dog module functions inside my main notebook file, so I'm making sure that all three of these are part of the same directory. Let's try to import the functions from the cat module. I'm going to use the from cat import star to do that. What do you think will happen if I call the speak function now? It's going to print meow. That's because the cat module speak function replaced the dog module speak function. What would happen if I were to call the fetch function? That would still return a stick. That's because cat module does not have a fetch function. With this style of import, whatever you're importing recently will replace the previous version of the function which has the same name. It is not uncommon to have multiple modules which have the same function name. There are open source software projects out there which have millions of lines of code which no single human being has read. The ability to create functions enables us to maintain such software projects because as long as we are able to understand how to use the functions, we can continue writing the program. Let's learn about the second style of import, which will enable us to use the speak function inside the dog module at the same time as using the speak function inside the cat module. For the second style of import, I'll have to say import cat and import dog. When you use this style of import, you'll have to use a different style to call the functions. If I want to call the dog module speak function, I'll have to say dog dot speak open parenthesis close parenthesis. By saying dog dot, I am explicitly mentioning that I want to call the speak function inside the dog module. Similarly, I can call the speak function inside cat module by saying cat.speak. If I want to call the fetch function inside dog module, I'll have to say dog.fetch. Let's learn few useful function calls and operations with respect to module exploration. Let's try out the type function call on a module. I'm going to call type and pass cat as the argument. Observe that the return value is displaying as module. Similarly, type of dog will be module. Let's learn about the DAR function. The DAR function enables us to get a list of all the function names defined within a module. For example, I can call the DAR function on the dog module. You can ignore all the function names that begin with a double underscore. Those are internal Python functions. Instead, focus on the function names which do not begin with the double underscore. That would be fetch and speak here. I can call the DAR function on the cat module. That will display to us that cat module has a speak function. Can I call the DAR function on the math module? That's going to give me an error. I thought we used math module functions previously. Let's scroll up to see what we did there. Looks like we used the previous style of import. If you want to use the DAR function, you'll have to use the second style of import. So I'll have to say import math. Let me do that. I'm going to type in import math and I'll run this cell again. Notice that you're getting a list of all the math module functions here. Very useful function to get a list of all the supported functions. Let's go through demo for one of these functions, which is the ceil function. If you were to guess what the ceil function will do, you might tell me that it will round a floating point number to the closest whole number, which is the integer 5 in this case. How can we find the documentation for a particular function within a module? The way for you to do that is to type in the module name, which is math, dot the function name, which is ceil, and then after that you'll have to type dot underscore underscore doc underscore underscore. This will give you the document string for that particular function. Observe that you're getting a string as a return value. A better thing would be for you to call the print function so that you get the formatted output. The function description says that you get the smallest integer greater than or equal to x, which was our guess. One thing which I want to bring your attention to is the fact that I'm using the ceil function without using math dot at the beginning. It is possible for me to do that because I've imported math functions in both the style of import. I used both from math import star at the beginning of the notebook, and I also used import math down below. Because I have the first style of import, I'm able to call the ceil function without saying mat.ceil here. Let's see how we can get the doc string for the dog module speak function. Can we just call dog.speak dot underscore underscore doc underscore underscore? That's not going to Sorry, looks like I have an old version of my module here. Let's try to call cat.speak underscore underscore doc underscore underscore. Notice that you're not getting any output here because the cat module does not have the documentation for the speak function. The way that you can create a documentation is very simple. You can just type in double quotations in the first line and type in the string. Let's say that I want to say cat says meow as part of the description. I'm going to save the file and we can try to run this cell again. Notice that nothing happened. That's because you need to restart the kernel and run your import statement again. So it will not help you if you were to type in import cat one more time here. That will still not give you the updated version of the doc string. So I'm going to scroll all the way up to the cell which had an error and I'm going to comment that out. when you have a cell which contains an error and you perform kernel restart and run all, your execution will terminate here and the cells below that will have to be executed manually. I don't want to do that, so I'm commenting out the cell which has an error. And now I'm doing kernel restart and run all, and observe that this time we are getting cat says meow when we run the doc string cell for the cat module speak function. Also observe that the document string description went away from the dog module. That's because I had a stale version of the dog module in the previous execution. If I wanted to add the document string inside the dog module, I'll have to type in within double quotations something, dog barks here. Let me just type in that string. As opposed to using docstring, you can also use comments inside your modules that will help the person who is trying to read the function as a programmer. Let's do kernel restart and run all one more time. And this time we'll observe that the dog module document string returns dog barks here. I'm going to go through one important function from the time module. I can import the time function inside the time module by saying from time import time. Observe that the module and the function has the same name. You can call the time function to get the current time. Why is this useful? Looks like we are getting some floating point number here, right? That's because you're getting the time in seconds from the UTC original time. You don't need to understand the details of how the time display works. Instead, we are going to see how you can capture time to time the program execution. I'm going to capture the result of time function call here into a variable called start underscore time, and I'm going to simply print something. Let me just say we are about to find how long print takes, and then after that I'm going to capture the time module time function's return value into a variable called end time. And now I'll be able to time my print function call simply by saying end underscore time minus start underscore time here. Let me print this so that we can see how long the print function call here took. Looks like you're getting the difference in the time in seconds. This is useful because you'll be able to get the time in the initial cells within your project notebook file. And if you repeat that in the final cell by saving the result as end underscore time, you'll be able to compute how long it took for you to run your project code. Let me switch back to the slide deck, and we are going to talk about one thing with respect to return values. The return values inside a function call is final, which means that as soon as you encounter a single return statement, your program execution for that function call is going to return to the place where you called the function. Let's go to Python tutor to go through a quick demo for this. I'm going to go to the course website, click on Python tutor, then I'm going to click on live programming mode. Let me create a simple countdown function. Let me call that as countdown underscore v1. In my version 1, I'm simply going to print 1, 2, and 3 here. Notice that nothing happens when I define the function. That's because I'll have to call it. So I'm going to say countdown underscore v1, open parenthesis, close parenthesis to call it. Let's step through this problem from the beginning. The first time when we run the function definition, it's going to jump over directly after the function definition to the function call line. This time when we go back to the function, we will be executing every line of code. Let me go back to the beginning one more time. when you run the code with the function definition, your program execution will simply skip over to the first line after the lines of code within the function. When you call the function, it will switch to the function call again, function definition again, and this time it will go through every line of code inside the function. Notice that you're getting the function name in the visualization here. For now, you don't have to worry about it. Eventually, we'll learn what that means. Observe that we got the display as 1 to 3 out of the countdown function. What if I were to take this function and change that into return statements instead of using print? So I'm going to change all the 3 print function calls to a return statement instead. As I mentioned, the return execution is a final line within your function call execution. So if I were to call countdown underscore v2 function now, what will happen now is that it will execute the first line, which will return 1, and then after that your function execution is completely done and you'll return to the place where you're calling the function. Let me capture the return value into a variable called retval, and I'm going to try to display retval here. So notice that we only got 1 from the second execution here. If I comment out the first function call, you'll only get 1 here. What is the point of having multiple return statements? We are going to learn about conditionals as part of the next few lectures. You're going to see how to use different return statements for different conditions within your program. I'm going to wrap up today's lecture by quickly going over the interactive exercises that are included as part of today's lecture entry. These interactive exercises enable you to go through some of the worksheet problems in an interactive way. I would recommend you to first go through all of these problems using the worksheet without having the Python interpreter or the interactive exercises access. So let me show you how the interactive exercises work. First of all, you need to log in with your Whisk account, and then you need to go through which line of code will get executed next. So you're supposed to click on the exercises. Right now, the execution is in line 1. So the next line that will get executed is the function definition line. Remember that when you define the function, you'll skip over the lines which are included in the function body. So I'm going to click on print C directly. Observe that when I clicked on print C, we got the display for previous print function call, which displayed A. The next line is going to call the foo function. When you call a function, you need to go back to the function definition line, and this time you're going to execute the function body. You're being prompted to answer a question here, which is asking what is going to be printed when the current line is executed. I know that B is going to be printed, so I'm going to type B, and looks like I got the correct response here. So after the function calls execution, you're going to return to the line of call. Since you're not doing anything with the return value in line 6, you're going to directly execute line 7 here. When I call line 8, that's going to call the function one more time. We have another question here which is saying which function is being called. I'm going to specify foo, then I'm going to click on check. One more time we'll be calling the foo function. Let's print B again. Since this is the last line of the program, I'll have to click on line 8 to complete the problem. Alternatively, you can go through this code using the regular Python tutor tool. If you click on edit this code, then click on live programming mode, that's going to give you the ability to just use the first, next buttons in order to understand the program execution. I would strongly recommend you to use the interactive exercises to first go through the problem on your own. before you try to use Python tutor to confirm your theory. That will be it for today's lecture.